Hi, welcome to the world of dynamic programming. I have come across many tutorials and articles regarding dynamic programming, and I found it extremely difficult to understand the solution and other properties of dynamic programming like overlapping subproblems and optimal substructures. So I thought of sharing the knack of understanding and solving dynamic programming problems at ease. In these tutorials, I will solve the problems and I will share the code to you. So the only prerequisite for this tutorial is you should be aware of C programming and you should have a Visual Studio IDE. So let's dive into dynamic programming. I would call dynamic programming as smart recursion. So let's refresh our recursion basics and then we can explore smart recursion. So a recursion is nothing but a function calling itself. So for any recursive function there should be base conditions, base or terminating conditions to avoid stack overflow. Okay, let's understand this first. So I'm giving an example. Write a program to print 5 to 1. So this is a program. We have to write a program to print 5 to 1. So the obvious solution everyone tries is int I is equal to 5, I greater than 0, I minus minus, and printf %d space comma I. So this is the for loop which prints the number from 5 to 1. Let's write a recursive function for the same. So void print numbers and it takes an argument as int n. So we will print the number n %d comma n, and as this is a recursive function we will call the same function but with different number, that is n minus 1. So as mentioned, so for any recursive function there should be a base or terminating condition. If n is equal to 0 we are returning. If the n is not there, this condition, the base or terminating condition is not there, then we will see a stack overflow. Okay, let's print this. N is equal to 5. Okay, let's printf printing using recursion. Okay, in the meantime you can also try along with me. Okay, so let's debug this. So now as you see the output, this 5 to 1 is printed using for loop and this one is printed using recursion. Okay, so whenever we don't add any base condition or terminating conditions, now if we don't add this and we try to call this recursion, so an infinite recursion will occur and you will see a stack overflow. So this is the error, a stack overflow error will occur. Okay, so it's always important to write a base or terminating condition to avoid the stack overflow. Okay, so this is a recursive function to print numbers from 5 to 1. Let's write one more recursion function. So write a program. So before writing the next program, let's understand how this program works. Okay, so if you try debugging this, so the n value is 5 is printed and you are calling the same function. Now the n value will be 4. So if you see, the n value is 4. So whenever you are calling this function again and again and you are passing a new number, so it enters into a different state. Okay, now the n value is 4. This is the fourth state. Okay, you can assume like that. Now again you're calling n value, you have printed the value 4 and you're calling the same function with different value, that is 3. So the program has entered the state 3. So like this it keeps on entering the new state. So recursion function will enter a new state. So you can see the recursion tree. So initially it entered print number 5, n value is 5, we have printed 5 and we have entered a recursion. We have called the same function but this time with different number. This is 4, so it entered a different state 4 and now it is printing 4. Now again you are calling the same function with different value 3. It is printing 3 and it is calling again the same function with different state, different number you can call. It is 2, you are printing 2 and you are calling the same function again with n is equal to 1 and it prints 1 and it will call the same function again with n is equal to 0. But we have kept a terminating condition saying if n is equal to 0, return. So we are not printing anything, or nor we are not calling the same function again. So recursion is going to stop when n is equal to 0. So when n is equal to 0, we are returning, and from here we are returning. We are returning to 3. We are returning to 4th state. We are returning to 5th state, and from here we are returning to the main function which is being called. Okay, so if you see this, till now we have printed 2. So now we are printing 0. It has written 0. So it is going to previous states and it is entering to the main state. If you see the output, 5 4 3 2 1 is printed. So in each and every recursion it will enter a different state. So you have to remember that. So recursion is a function calling itself. There should be a base or terminating condition to avoid the stack overflow and to complete the recursion. Now let's take one more example. Write a program to print 10 power 5. So we have to write a recursive program to print 10 power 5. So 10 power 5 we can depict it as 10 into 10 power 4. Okay, we can think as 10 into 10 power 4, and for 10 power 4 we can think as 10 into 10 power 3, and for 10 power 3 10 into 10 power 2. For 10 power 2 we can rewrite it as 10 into 10 power 1, and for 10 power 1 10 into 10 power 0. So anything which is 10 power 0 is 1. Any number to the power of 0 is always 1. So this is 1. 1 into 10 is 10. Okay, so 10 power 1 is 10. 10 into 10, 100. So 10 square is 100. So 100 into 10, 1000. 10 cube is 1000. So 1000 into 10, 10,000. So 10 power 4 is 10,000. 10,000 into 10 is 1 lakh. So 10 power 5 is 1 lakh. So we are returning 10 power 5. Okay, so int power 10 int n is 5 here. Okay, so the base condition is if n is equal to 0, we are returning 1. That is important. So the base condition is important, and we are returning 10 into power 10 of n minus 1. Okay, 10 into power 10 of n minus 1. So this comes as 10 into power 10 of 4, and then 10 into power 10 of 3, and then 10 into power 10 of 2, and then 10 into power 10 of 1, and then 10 into power 10 of 0. So power 10 of 0, when n is equal to 0 it will return 1, and 10 into 1 10, and it keeps on unwinding, I mean going back to the previous states. Okay, so now when you printf, okay, 10 power 5 is, you can call power 10 of 5 percentage t backslash n. Okay, now try running this program. One second. Yeah, so 10 power 5 is 10 power 5 1 lakh. Okay, next one more program. Write a program to print a power b. Okay, int a power b. So for example, you can consider as 5 cube. You can consider a power b as 5 cube. So 5 cube, you can rewrite it as 5 into 5 square. Sorry, 5 into 5 square. So 5 square, you can write it as 5 into 5 power 1, and 5 power 1 you can write it as 5 into 5 power 0. So the 5 power 0 value is 1, 5 into 1 is 1. So 5 power 1 is 5, 5 into 5 is 25. So 5 square is 25, and 5 into 5 into 25 is 125. So 5 cube is 125. Okay, so int a power b int a comma int b. So we have to write the terminating condition or base condition. If b is equal to 0, which is nothing but 5 power 0 is 1. If b is equal to 0, we return 1. Else return a into a power b a comma b minus 1. Okay, so we can print that also, a power b 5 comma 3. Okay, let's rewrite as 5 cube. Let's debug this. Okay, a value 5, b value 3. We can add these variables to watch. Okay, a is 5 and b is 3. Now debug. Okay, as b value is 3, this condition is not satisfied. Now 5 into 5 comma 2, 5 power 2. Okay, now this will enter new state. Now the new state is 5 comma 2. Again it will check for the base condition, it didn't occur yet. So now again 5 into 5 comma 1. So now it will again enter new state 5 comma 1. Now it didn't encounter the base condition. So 5 into 5 comma 0. Now the base condition satisfies b is equal to 0, so it will return 1. Okay, so the values are calculated and they are returned from here. And now if you see, 5 cube is 125. Okay, so in any recursion, the base condition is more important. And one more thing I want to say, you always think about, when you are writing a recursion function, you always think about the first depth. So the recursion function, what you are writing, the what base conditions you are writing, you always think for the first level. Don't go beyond the first level. If you think like that, you may miss something. Okay, so any recursion function, for writing base condition or for writing the main condition, you always just think about the main function. Sorry, the first depth level thinking is most important. Okay, don't think about the fifth level or sixth level depth. Okay, in this example this is the first level, second, third, fourth, fifth. So if you think about the last level or next level, you may miss out somewhere and you may write a wrong program. So always think about the first level and write the recursion accordingly. Okay, so let's write the last recursion function. Write a program for GCD. Okay, GCD is greatest common divisor. So for, you might have done in your high school maths, so GCD of 12 comma 42. Okay, so find out the GCD of 12 comma 42. The original method that you use is 12 3s are 36. Okay, 12 3s are 36. Answer is, the remainder is 6. Now in the second state you will take this remainder 6 and 12. Okay, right, this is what we learned in the high school. Now we take the remainder of 12 and 42 and 12. Now 6 2s are 12 and the remainder is 0. So when you encounter the remainder is 0, the GCD is 6, right? So in the same way we have to write a recursion function, int GCD of int a comma int b. Okay, what is the base condition and what is the main condition? So in this case you just think a as 12 and b as 42. Okay, in the first state a is 12 and b is 42. So in the second state, when in the next depth, what you are thinking, for that a will be nothing but a remainder of current state b and a, right? In the second level 6 is nothing but a remainder between current state 42 and 12. Okay, so return GCD of b percentage a comma, and in the second state b is nothing but current state a. Okay, right? So in this second state b, what we have to divide is nothing but current state divisor, which is nothing but 12. So this is a. So this is the main formula. So whenever you have encountered b percentage a in this second state, b percentage a 12 percentage 6 is 0, right? So whenever a is equal to 0, the answer is b. Cool. Okay, let me explain again. So in the first state a is 12 and b is 42. For the second state a is 6, b is 12. Okay, so second state a is nothing but first state b percentage a. Okay, and the second state b is nothing but first state a. Okay, cool. So whenever a is 0, you return b. Okay, let's test this. Let's see what it returns. Percentage n 12 comma 42 GCD is percentage d slash n comma GCD of 12 comma 42. Okay, okay, now a is, okay, this is the previous thing. Okay, yeah, 12 comma 42 GCD is 6. Cool. Okay, so take few homework problems. Write a recursive function to print sum of all numbers from 1 to n. Write a recursive function which returns product of all numbers from 1 to n. Product of all numbers from 1 to n. Okay, this is also same way. Write a recursive function which returns sum of all numbers from 1 to n. Okay, take this to as homework and work it out. And the current programs, you can find the link below the video from where you can access the current program source code. Okay, catch you in the next video. Have a nice day.